Hi, welcome back to my channel. This is Harshita from Sri Venkateswara College of Engineering from ISC department. We are gonna see about object-oriented programming with Java, which is OOPS with Java. We are gonna see about recursion. Recursion. In Java, recursion is a process in which a function call itself directly or indirectly is called recursion and the corresponding function is called as recursive function. Using the recursive algorithm, certain problems can be solved quite easily. A few Java recursion examples are TOH indoor pre-order post-order tree traverser. The base condition in the recursion as given below. Working of recursion. The idea is to represent the program in the terms of one or more smaller sub-problems and add base conditions that stop the recursion, which is given below as the example. Factorial using recursion. In this code, there are two classes, GFG and the recursion. The GFG class condition a method called fact, which is the recursive method used to calculate the factorial of the given number. The fact method takes the integer n as the input. Inside the fact method, there is an if else condition. It checks if the value of n is equal to 1. If it is, the method return 1, which is the base case for the factorial calculation. If n is not equal to 1, the method calls itself recursively with the parameter n minus 1. The multiplies the result with n. This recursive calls continues until n reaches the n, and then the calculated factorial value is returned. Moving on to the main function in the recursion, class instance of the GFG class is created using the GFG f is equals to new GFG statement. This allows us to access the fact method. The system out dot print ln system are used to print the factorial values of different numbers. In this code, the code calculates and prints the factorial of 3, 4, 5 using the fact method of the GFG class. How is memory allocated to different function calls in the recursion? When many function is called from the main is allocated to it on the static, a recursion function call itself. The memory for the call function is allocated on the top of the memory allocated to the calling function, and the different copies of the local variables is created for each function call. When the base case is reached, the function returns its value to the function by whom it is called, and the memory is deallocated and the process continues. And this is the program which has been given. In this code, we have class called GFG inside the class. There is a static method called print function that takes an integer parameter called test. The function method is a recursive method that prints the sequence of numbers in the specific pattern. There is how it works. If the value of test is less than 1, the method returns and the recursion stops. If the value of test is greater than or equal to 1, the method executes the following steps, which is it prints the value of test using the system.out.printf statement. If system if it calls the print function method again with the parameter test1, this is the recursion point where the method calls itself with the smaller value of the test. After the recursive call, it prints the value of test again. In the main function, an integer variable test is declared and assigned a value of 3. Then the print function method is called the test variable as an argument. When you run this code, it will print the number in the following pattern: 3, 2, 1, 1, 2, 3. The pattern is achieved by the recursive call, and the order of the print statement. And this is the explanation of this program. Advantages of recursive programming. Recursion provides a clean and simple way to write the code. Some problems are inherently recursive, like a tree traverser, uh, TOH, etc. Such problems it is performed to write the recursive code, reduces the time complexity, performs better in slowing the problems based on the tree structures. Disadvantages of recursive programming. The recursive programs has greater space required than the inheritive program, as all the function will remains in the stack until the base case is reached. It also has the greater time requirements because of function calls the return overhead. Recursion uses more memory, which is the difficult to understand. Difference between the direct and indirect recursion. A function is called direct recursive if it calls the same function. A function is called indirect function if it calls another function, says new, and new calls function directly or indirectly. In direct recursion, function calls itself directly in its own body, whereas indirect recursion typically involves at least two functions. A function calls a second function, which then calls the first function again. Example for indirect recursion. In For instance function A calls function B, which calls function C. If function C under any circumstance calls back to the function A. This case is the case of indirect recursion. Direct left recursion occurs in one diversion step. Indirect left recursion takes more than one step. Types of recursion. There are several different recursion types and terms. Direct recursion. This is the uh, typified by the factorial implementation where the methods call itself. Types of recursion. There are several different recursion types and terms. First, direct recursion. This is the recursion factorial implementation where the method call itself. Mutual recursion. This happens where one method, say method A, calls method B, which then calls method A. This involves two or more methods that eventually create a circular call sequence. Multi recursion calls are made in the method. Head recursion. The recursive calls is made at the beginning of the method. Difference between tail and non-tail recursion. Tail recursion, a recursive function is said to be tailed recursion if the recursion call is the last thing done in the function before returning. The base case is handled at the end of the function after the recursive call. Tail recursion can be optimized by the compiler to use the constant amount of stack space, can be optimized for the tail call limitations, improving stack space efficiency. Non-tailed recursion. A recursive function is said to be non-tailed recursive if the recursive call is not at least done in the function before returning. The base case is handled before making the recursive call. Non-tail recursion use more stack space because each recursive calls creates a new frame on the new stack. It cannot be optimized for the tail call limitations, which can be led to stack overflow errors. Thank you.